Hello everyone, this video is the continuation of my previous video. So I'll just give you a quick recap. So over in my previous video, I was talking about coefficient of variation, and then I have given these example where you can find out when there is a positive correlation or positive covariance, negative correlation, negative covariance, and no correlation, no covariance. So the formula for the covariance, like how you can calculate it. So the formula for covariance is like covariance of two variables, right? Because we find the relationship between two numerical quantities. So it is like this xi minus x bar, then yi minus y bar, divide by sorry, divide by n minus 1. So this is the formula for calculating the covariance, and this is the mean of variable 2, and this is the mean of variable 1, like whatever the variables which you are comparing, and this is the number of data points. Okay, number of data points. Then the formula for correlation is correlation of x comma y is represented by rho of xy. So this you called rho, actually it is called as rho, is represented by standard deviation of xy upon standard deviation of x into standard deviation of y. So this is the formula to calculate the correlation. Also, I would like to give some extra information, like if correlation is equals to 1, okay, it means it is positively correlated. If correlation is equals to -1, it means it is negatively correlated, means there is no correlation. Not exactly, sorry, no correlation, but two variables are not correlated. And if correlation is equals to 0, it means two variables are totally independent. That means there's not even a single nothing, no relation is there, right? So please remember this. What is the meaning of correlation equals to 1, -1, and 0? And also one more thing I would like to explain here, like in covariance you have unit information, okay, and in correlation the unit information is not there. So if you are comparing two variables, right? So for example, if you want to compare the age with the salary, so the salary will be in dollars and age will be between 1 to 100. So you cannot compare these two numerical values, right? Because they have a different unit. So there will be no difference. But if you do the same with the correlation, you like correlations free of a unit, you don't put any kind of unit over there. So it will be like there will be no unit over there, and then you can compare the two variables. So yeah, you can go for correlation and covariance based on the requirement. Now other things which I have to discuss is like so we have covered measure of central tendency, measure of spread, and now we have to cover measure of asymmetry or skewness. So this is also very important actually. uh, so under measure of skewness, we have Pearson's calculation. So inside that we have our mode skewness and median skewness. I'll just talk about it. Um, so when I talk about skewness, right? What exactly skewness means? Um, so I'll first explain this. What is the mode skewness? So skewness here is equals to formula is mean minus mode divided by standard deviation. Okay, median skewness is 3 multiplied by difference between mean minus median. So this is how you can calculate these things. You have to remember these formulas actually. And there's one property called mode is equals to just extra information 3 times of median minus 2 times of mean. So sometimes in interview you can find such kind of questions. So for that purpose I'm explaining, just giving you. So then we have moments based calculation, that is the first moment, second moment, third moment and fourth moment. So I will explain each and every moment, just give me some time. So first moment is basically called mean, which is explained by summation of x by n. Okay. Second moment is the variance. The formula for variance is x minus mean square then n. Third moment is the standard deviation. Sorry, third moment is the skew. Formula for calculating the skew is 1 by n summation of x minus mu whole cube divided by cube of standard deviation. Then fourth moment is called kurtosis. Formula for kurtosis is I'll explain later. First, you should know like what are the types of kurtosis we have. So we have mesokurtic, hypokurtic, and platykurtic. So I'll first explain about the skewness, then we will slowly go into these things. Okay. So skewness is like where that your data is distributed. Okay. So 1 second, I'll just take some space. So skewness, like when we talk about, so skewness tell us where the data is distributed, okay? Distributed in a feature space. So there are basically three types: positive skew, negative skew, and no skew. So positive skew is like this one. So when you have data like this, when it is pointing towards the right side, so here this is called the tail. So when the tail points towards the right side, it means our data is positively skewed. Okay, so most of our data is towards this side, right side, and negative skewed means when our tail is pointing like this towards the left side. So it means, so here the tail is towards the left, okay? So it means the data is negatively skewed, and there are cases when the data is normally distributed like this. So here there's no skewness, okay? So the data is normally distributed at this part. Then we have something called so called bimodal, also concept of model. So if you see here, this is a single model, like we have only one mode over here. So sometimes we have data in this format as well, like where we have different types of peaks, multiple peaks. So it is called, there are three modes are there. So if we have two modes, so it is called bimodal. So here we have, so in this way, we can just define how the data is distributed. So just an additional information. So in case of positive skewed, uh, what is my mean, median, and mode? Okay, so what is my mean, median, and sorry, mean, median, and mode in this case? So if you see here, my data is distributed like this, okay? So my mode is this one. Then my median is in the middle, right? Median is the central of uh, sample data. We have just talked about it, and this is the mean. So we can just say mode is less than, median is less than mean. Okay. in case of positive skewness, you have to just remember these things. And in case of negative skewness, like if it is like this, my data is like this, sorry, it's not drawn properly. So if my data is something like in this way, like if it is negatively skewed, so over there my mode is this one, and my median is towards the left, and this is my mean. So here mean is less than, median is less than mode. Okay. And in case of this thing where my data is normally distributed, so all the mean, median, mode, it will lie here. Mean is equals to, median is equals to mode. So you have to remember these things. And yeah, that's all about it. Now I will discuss about, so we have already discussed about the variance and mean, and now I will discuss, I have already discussed about the skew. Now kurtosis. So when I talk about kurtosis, so it means like I'm just talking about the skewness, how peaky your data is, uh, peakness about the distribution. So for example, if my data is like this, uh, in a feature space. Okay. So it's very peaky. You can see here, right? So it's very pointy over here. And if I'll just explain the different types of kurtosis. So if you see here, uh, this is my, it is very pointy. Then for uh, mesokurtosis, it is like this, little bit smooth, and leptokurtosis is little bit peaky. This is my leptokurtosis. Lepto. This is meso. Okay, and this is platy, like little bit towards the downside. So this is my platykurtosis, and there is a way to calculate the kurtosis. It is measured by beta value, that is beta 2 value. If the beta 2 value is equals to 3, the curve has normal peak. So if you see here in mesokurtosis, it is looking like a normal peak over here. It is not very pointy, it is not towards the downside. When beta 2 is greater than 3, curve is more peaked than normal. So in case of leptokurtosis, you have seen, right? So in case of leptokurtosis, it is like little bit peaky. So when beta value is greater than 3, it will be peaky. And when beta value is less than 3, it will be less peaked than normal, okay, in case of platykurtosis. Then formula for calculating the beta is, it's you sometimes you just have to remember a lot of formulas in this, but it's not that tough. So xi minus mu whole square divide by standard deviation, okay, and whole thing you have to divide by n. So this is the formula for calculating the beta value. Okay, so based on this beta value, you have to calculate the value of kurtosis. So yeah, this is all about descriptive statistics. So we have something called inferential statistics, where we have concepts called maximum of likelihood, Bayes estimator, best unbiased estimator, and there are some other concepts like confidence interval, standard error, p-value, alpha value. So those things I will be discussing in my next video. So yeah, if you really like the content of my video, please do share, subscribe, and hit the like button.